Hey everyone, welcome to today's support. Today, let me show motion controller data and storage. Similarly, we need to do wiring for controller. Please see right graphic and there are some required materials. Then, let's learn some basic theories. Firstly, variables. Variable is the parameter that can be customized by users. It is used to temporarily save communication data with external equipment, or data that's processed by tasking side. Namely, it saves data that is with property, such as name or data type. And there is no need to assign address allocation between variables and memory addresses. Please note the length cannot exceed 17 characters. About variables, there are 3 commands to define variables: global, file module, and local variables. They define different contents for variables, and one project can include multiple files. For global type, it can be used in all files. For file module type, it only can be used in this file internally. For local type, it is only used in sub. In addition, it is valid to assign directly without a segment, but it is file module type only. Below shows these 3 variables definition examples. Let's see the second one, constant. Constant only can define one data at a time, and attention, define it and assign it in the same line. Constant can be defined as file constant or global constant. Same, global is used in all files, but there is no way to write local const. There are some common constants, such as Boolean type, character string type, time type, date type, integer type, etc. These are 2 examples: file constant definition, global constant definition. Then, array. Array assignment means that define the data of the same attribute after they are collected, and then define the number of data. For the data that consist of the array are called elements. The data types of custom variables and arrays are 32-bit floating type, but for ZMC4 series or above, they are 64-bit floating type. Global and dim are relative instructions, and here shows file array. And this is global array definition method, but note the number cannot exceed the range, otherwise the program will report the error. Next, subfunction. It is defined by subcommand. It can be file sub or global sub, but for cross file calling, it must be global sub. The subprogram can be called in the program, or be called by task command. Namely, it is called as one single task. Following is example. Define through sub, and use and sub to over. Now, enter register information. There are 4 registers: table, flash, VR, and modbus. Firstly, connect to controller through ZDevelop. Click controller, state the controller, or input $max. Both could show relative information. Let's see one by one. Table is a very large array that comes with the controller, and the data type is 32-bit floating point. But it doesn't support save data when power off. When writing a program, the table array can be used directly. The index subscript starts from 0. Some instructions of the basic can directly read the values in table as parameters. Values in table save parameters in one certain position in table, then call table data through instructions, such as cam command, robot command, hardware comparison output. Parameters sampled by the oscilloscope are also stored in the end of table array. Therefore, attention to the allocation and use of multiple table areas. do not overlap with the data storage area sampled by the oscilloscope. Here shows how to use table. First one, read and write data. It can assign one data or data in bulk. Second one, read and modify table space. Please use TS command. Third one, print character format. Use table string command to convert to ASCII code form. Flash supports power down storage. The data will not be lost if it is not powered on for a long time. Therefore, it is generally used to store large data, and data does not need frequently reading and writing, such as processing files. When reading and writing, ensure that the names and order of variables, arrays, to be operated are highly consistent. If they are inconsistent, data will be cluttered. When flash is used, it is numbered as per block, and the number of blocks can be checked through flash sect's instruction. Below shows the method. VR register. VR also supports power failure storage, but the data volume is small. Then it saves those data need modifying all the time. Why it will not lose data when power off? Because there is one power shortage memory inside, and the data type is 32-bit floating point. Use VRInt to force an integer with 32 point, and use varstring to force a string. The saved data is ASCII code. One character occupies one VR. VRInt, varstring all share a space. Read and write methods are the same. The last one, Modbus. Modbus communication data are saved by Modbus register, and controller Modbus register conforms to Modbus standard communication protocol. There are word registers and bit registers. Modbus bit register, and it is Modbus 0x4HMI. These are word registers, and they are Modbus 4x4HMI. We could see Modbus word registers in the controller occupy the same variable space, and one LAN or one IEEE occupies two REG addresses. But when using, attention to stagger their addresses. Here shows details. Front 8000 are customized by users. Remain are for system data. Then let's see the operation of Modbus storage. Actually, Modbus communication needs to transfer data in Modbus registers. There are specified Modbus communication instructions to read and write the data or transfer data between other registers. Please refer to write instructions. The Modbus read and write grammar format is the same. Get means read, set means write. But word register and bit register are different from reading and writing. Please refer to the basic manual for details. This form shows commonly used register data types and value range of each unit. As mentioned before, data can be converted, but actually it may cause some problems when in motion. Let's see. Number 1. Lose data. When the floating point type is converted to an integer type, the decimal part will be lost. For example, convert VR to REG. The result became 10 behind are lost. Number 2. Compulsively convert. After the integer is stored in the floating point register, it will become a floating point type. But when you use integer to operate, the data may be incorrect. Number 3. For single precision data, there are only 7-bit valid values. If there are long-term accumulated values during the calculation process, it is better to use CMC4 series controllers because of their double single. The last, as usual, open our ZDevelop to display example. Open edited program in ZDevelop. Connect to simulator. Download the program. There are two tasks for this program. Adopt modular programming. Automatic run tasks 0 is the main program. In the main program, call different functional modules. Task 1 is also opened in task 0. As we know, basic program scans from the top to bottom. Firstly, it executes emergency stop and clears motion buffer. When access 0 is paired, call each initialization module, then jump to corresponding subfunction to execute. It shows the first is the constant initialization module. Then we put the mouse in function aim. Right-click. Select this one item. Now it jumps here. Define total axis. Then return when and sub. The second, execute variables initialization module. Same. It defines and selects flash block number. Define data space that is to be used for storage. And use for loop to clear arrays. Then return to execute access parameter initialization module. Set all relative access parameters and save them respectively in IEEE register. For example, when I is 0, select access 0 and save access 0 units in address n. For access 0 speed, save it in address 12. Next, return to execute flash to read function. Use flash read instruction to read data from flash. The flash num, select the flash block number. Remain read from flash. The last one, execute CAN parameter configuration module. Save CAN parameters into table. At this time, variables definition and assignment are in the same line. It could be seen it is defined as file module variable. Select table 0 to table 1000 and save data. OK, next execute while loop. If Modbus bit 0 equals to on, open task 1 and execute processing technology module. Trigger oscilloscope and select access 0. Assign parameters to m, t and speed. Execute CAN instruction. Call the data from table 0 to table 1000. The times is m. Motion distance is multiple speed entity. After 5 CAN motions are executed, task 1 stops. If Modbus bit 1 equals to on, stop task 1 and repeat the stop access motion. If Modbus bit 2 equals to on, assign relative data and write data into flash block as sequence. Please note the sequence must be consistent. Now, we learned this program. Next, use oscilloscope to display. Enter Modbus bit 2 equals to on. After initialization is done, set while CAN parameters used in task 1 and write them in flash block. If it's success to write, you will see this. Then open oscilloscope. Set corresponding parameters. Here, select the pulse and m speed of access 0. Start. Enter Modbus bit 0 equal to on to open task 1. Then oscilloscope is triggered to sample. CAN instruction is executed, and we get relative waveform. When in motion, enter Modbus bit 1 equal to on axis will stop rapidly. Okay, today knowledge is over. See you next time.